Hi and welcome to my playhouse, and today we have a little project. It's the robot lawnmower, and it's a beautiful day today, and I would like to show you what I've done since the last video where we put down the wires and stuff. The lawnmower is over here. We did see that. Right now it's waiting. It's supposed to be turning on at about 10 o'clock, and we are not there yet. Right now the time is, it doesn't say, but I have made it to run off solar since we saw it last. So up here I have a 50 watt solar panel. It's the tiny one, the little one here, and there is also the windmill that, well, it doesn't produce much power, that's for sure. But I run the cable, that's the white cable that goes here, and it runs into my garage. And in the garage, let's go in there, I have made a little setup. Oops. Over here the white cable comes down from the solar collector. This cable is from the windmill, and it goes into this wind and solar charge controller, which I've had for years. It's I don't think it's very good, but it does charge the battery, and I've put a big battery up here which it charges. And right now it also controls this inverter over here. So the inverter, right now I have just paralleled the inverter with the batteries because this charge controller was giving me some trouble. Well, I have a 150 watt inverter that converts to 12 volts to 220 volts, and I plugged in the charger of the lawnmower here. Right now it's green. The lawnmower is somewhat charged, and well, we can just see the voltage here. If I can manage that, can I do that? Get a voltage there. We can see there is almost 13 volts on that battery, 12.99. So that is all good. Let's turn this off, otherwise the batteries will run dry. I have the problem that the batteries in the robot lawnmower is really bad. It will undock and it will drive around for 5 minutes and it will go charge again. And well, it will mow the lawn for 5 minutes, and then it will use 10 minutes to try and get back to the docking station. So I need to make a new battery for it, and I have started that process in the basement. So in the first video about the robot lawnmower, we opened up and found out that it had 2 of these batteries. Not exactly this brand, but this size of batteries. And as these batteries are pretty much the same thing, it has 2 of these. They are 12 volts and they are about 5.8 amp hours. So 12 volts, 5.8 amps for an hour. And that's what the lawnmower runs off. So I want to change it to run on lithium ion batteries, and I had these cells here which are really cool. They have come out of Apple machines, and they are just a little bit taller than the battery, but I believe there is room for that. So I want to make a 24 volt battery out of this. And I'm just so lucky that I have a BMS, that's a charge controller balancing module for lithium ion batteries. So you connect 7 of these batteries in series. Tick, 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 tick. These are about somewhat from 3 volts to 4.2 volts in voltage, depending on if they're charged or discharged. And 7 of these in a series will give you 24 volts ish for the lawnmower, and that's what this little device will handle, and it will do 30 amps. We are not gonna need, oh, it actually says 50 amps. So okay, we definitely do not need 50 amps. We could do with 5 amps, that would have been fine. So, but 7 of these batteries, well, we can do better than that. So my thought is actually I will put 3 batteries in parallel and then 7 pairs of these, and we will have a beefy, good, everlasting battery, almost. So the batteries comes out of these packs, which has been probably located in a laptop. I have a bad one here. There's a big beefy hole in that battery, so that's not gonna be good. I'll dispose of that one, but I take them apart and it's like gluey thing, but it has these awesome 4 cells, and each of these cells they are 14 watt hours, and that is just about as much as 2 good 18650 cells. So 2 of these cells is about equal with 1 of these cells, so pretty cool. But this form factor is really good for what we are going to be using it for. So I will I'll check some of these cells. I will dismantle the last I only have 2 left of these, but I have this whole stack over here, so I do have enough. And that lawnmower will do a lot better on battery capacity if I can get this up and running, get it connected to this thing as well. I don't need to use very thick wires because I think the lawnmower uses about 1.5 amps of power, like 24 volts, 1.5 amps. It's nothing. A battery like this can do almost, I think it was 3.8 amps for an hour. Cool, it will be an awesome battery. So I need to cut these off. Get rid. I'm always a little worried about short-circuiting anything, but well, nothing bad has happened yet. So that wire is out of the way. Then there is this and that and that. 1 battery's out. And let's see what we have here. Let's take the other one over here. It should be about the same way. Another battery. So 3 batteries in parallel with 14 watt hours. Well, that's a considerable amount of power. Did I have one of these that was bad? Which one was that? Oh, that was over there. So all of these are good. Last one. There we are. Another one taken apart. And 4 good batteries. Hopefully we're gonna test them before we put them together. Okay, so this one is the one with the bad battery. I have to remember to dispose of that. I have started taking this apart, but this cell is like glued together, and there is some tape here. And I found that if I remove the tape holding the batteries, it makes it easier. So there are pieces of tape in each end here that I can carefully remove. Then I remove, there is protective tape over the leads of the battery, and if I remove that, it becomes easier to cut the cables. This is tedious work, and it takes a long time. But these cells are pretty expensive. If you go and buy just a single cell, that would cost you $10–20 for just 1 cell. So it's well worth it compared to buying new ones. I'm not gonna test all the batteries if they are the same capacity. Some of them might be more worn than others. I'm I'm just gonna wing it on this one. There. Then we have the possibility of removing some of the top here. Removing the plastic that is on here. We see the cables here, and that makes it way easier to get down and cut these things. But before we do that, when there's a hole in these batteries, it smells sweet. I am told not to sniff it too much, but yeah. The batteries are glued to the rest of the plastic, so applying some pressure and the glue will give up. There, and we have, this is the charging cable going out to this side. So we are at about where we were before, so I will continue this. Okay, back outside again. It's just about 10 o'clock, so I'm very excited to see if the lawnmower starts. Can I see the time down here? It's 9:59, so in less than a minute it should start. Oh, a minute is long to wait. I hope it starts. Oh, oh, oh. We were lucky, and it's off. It's pretty fascinating to follow the robot around the garden. It's just stupid, but it is. Oh, it's just gonna pass there? No, no, no. Pretty smart when it can feel that it's cutting a lot of grass and it's returning to the charging station. So it's pretty clear to see why it needs a new battery. It's done mowing for now, it needs charging. So that's why we need a new battery for it. So trying to find its way home to base. And it's following the cable. It's a lot of trouble to get it to follow that cable correctly and don't go out of its way to drop dead somewhere. I'm not sure if I got it up here. I think it got around that one. Then the next problem is that it has problems to get onto the docking station sometimes. The wheels will just slide around there. So I'll just give it a bit of a push this time. I need to do something with the dirt down here so that it can handle that better. Okay, all this talk about batteries meant that the camera got jealous, and that also wanted to get charged, so it has been charging for a little bit. In the meanwhile, I've been working in the basement here, and I've cleaned up all of these batteries, and this is my idea right now, is 3 and 3. I'm gonna collect them, tape them together in a little box like that. I had some batteries that was at 0 charge. These two were almost at 0. I have a couple of batteries charging here. I have just put them on the charger. They are set to 3 volts, half an amp. So that means that each battery will be receiving 250 milliamps. I don't want to damage them, so just giving it a little bit. I had one here that I put on the charger and charged with 1 amp, and that started to swallow up. So that's something I have to be careful about. It's a shame. I'm pretty sure these are very, very awesome batteries, so I don't want to waste them. So I'm working on this. Yeah, this is gonna be great packs. Okay, I've run into some serious problem here. I have tried everything, and I have a really hard time soldering on these metal things coming out of the battery. So, but I found on this one over here that if I take some copper wire and just runs it around these threads somewhere, I'm gonna do it pretty far down because I don't want the battery to be too tall. There. Kind of make like a mesh of copper in between. I can at least get the copper to bind to this whatever metal this is, because that's a problem. And I think I've been trying for half an hour to get the solder to stick on there, just to get this to work. So let's see if this isn't good enough. I will bend all of this out of the way and try and put some solder on that. Okay, a hell lot of soldering later. It looks like this. They're not pretty. I put a piece of wire on here. I thought that that would go to the next one, but I forgot about it, so I did all of them. But now it looks like this. I just checked that each of them are above 3 volts. They are. But now that the cells are in parallel, 3 and 3, we need to put them in series like that, so they can add up the voltage. And that's gonna be pretty interesting to do that. And I don't think that's gonna be a big task to do that. It's as if this plus wire is in the middle, so every time we're just gonna be swapping space from them for the minus wire, so that's probably gonna be okay. I'm gonna find the prettiest battery to put in front of the collection so that I can read the text. Okay, I have put them together, pointing in all kind of directions. It's not very far from the size of this battery. It's a little bit taller. It's kind of cool. It takes up the space of 1 battery. So I could make one more, but it's a big task to make these. Hours has passed. So yep, moving along. Okay, I have now connected this battery in series, and we should get some good voltage out the ends. Let's have a multimeter. Let's check that. Oh, that's become rather dirty. We are in view. So what do we measure? We need minus over here and plus there. So we have 23 volts. So the battery is not fully charged. It will go a lot higher than that. I believe probably almost up to 30 volts. But the BMS is gonna cut out before that. There was a little leaflet piece of paper, and it says that the cutout voltage is 29.4 volts, but it also depends on the voltage on the charger. But the BMS should protect this pack from not being presented with any over voltage. So the BMS here, I need to connect that up, and it even has a temperature sensor to connect to the batteries. So I found where I bought it. I bought this one on AliExpress. It's probably available other places. So I have, if we turn it that way, we have to connect the discharge minus over here. So the minus connection from where we connect the robot is there, and then we have charging, discharging. That's gonna be directly onto the battery, and we need to connect the first wire to the first battery, and all these batteries in series. And then we have the charging over here. That's those two, I guess. Discharge. I don't know about that one. The C. Oh, I probably need to. Okay, I need to figure that out. But I'm just gonna start with all the sensor leads, mounting those. And the first one goes onto the plus side of the battery, the other one, and then I just mount to all the pluses, and that should get me 7 wires. Okay, the work is progressing. I have mounted all the wires for this balancer, and it goes on the plus wire, and it's to measure that all the batteries are in balance. Yeah, it does that by we're charging the batteries, and it will draw a little bit of power between the cells if there is a cell that has too much power, and that way bringing that down a little bit, and then bringing everything up a little bit more. So but I've mounted the BMS and I've hot glued it onto the side here, so it's gonna be just about as big as the one of the old batteries. It's gonna be containing a lot more power than the old battery, so this is gonna be cool. I need to we need to mount this heat sensor. I think I can actually just stuff it down there somewhere. That will probably be fine. There, I think I'll just put a little bit of hot glue on that. Oh, hot. Just stay there. There. Okay, this probably looks like a damn mess, but well, I do believe that I'm charging the battery right now. I'm charging it, putting 25 volts. Oh, it has dropped. It's not taking more than half an amp right now. So if I up the voltage, it will take a little bit more. Okay. So this is how it looks right now. I have mounted some more leads on it. I think I need to go and disassemble the robot now. So we need a screwdriver for that. Okay, so here it is. I picked it up. It was on the way to the charger. So in the bottom of it, we have the cutting action here, and we have the battery department right there. There are 6 screws to take out to remove the battery, and we will see if we can manage that. I have had it out. We did have a look at it in my first video. There, and the battery compartment comes out, and there is there's a connector here that this whole thing goes down into. So let's just bring this back down into the basement. So another 6 screws taken out, and we have access to the battery department here. It's not complicated. There is 2 wires that comes from the lawnmower. They're not very thick, and they go out. Are they soldered on here? Did they really do that? Did they? They did. I need to desolder those connections. And there is a temperature sensor, so I'll be able to pop down my new battery in just one of these holes and pop this one out. It has a beefy 100 amp fuse. I probably should put a fuse on there. Okay, they had soldered these connections to the battery. That's a really good idea. Oh, it's still hot, but it's really difficult to get them off again. So I don't want to break this. If anything goes wrong, I can just put in a couple of new batteries. Ouch, still warm. And it would be good to go. So my old battery has to go in here and sit there. Probably there is some difference in height, so I think it might go in up here where it's higher. I think I need to protect my battery a little bit better. How did I gather that? Oh, I'm still charging it. Maybe I should just stop doing that for a little bit. There. Put the battery in like that. Bring the connections over here. I don't want to short circuit that. That's gonna be interesting to see if I can manage that. There are some thingies up here that I need to think about. Otherwise, I could just have it laying down, but I'll work a little bit with this and you'll get to see the results. Okay, so it has gotten some more tape and I have gotten this balancing cable kind of out of the way. Probably should have cut it a bit shorter, but well, you know, lazy. And it's ready to go in. So it can kind of sit in the bottom here like that. That's pretty cool. I found a fuse that I'm gonna be putting on here. We're gonna just connect the plus wires very nicely, and then we're gonna be putting on a fuse on the negative side, and I'm just putting in a 30 amp fuse, and I made it so that both of these can just connect to the fuse. So I think I need something to put in here so that the battery cannot move around at all. So I need to find some foam. Okay, I don't throw things like this out. So and I just found a piece and it fits almost too good to be true in here. So kind of like that. And I guess we can just put the cell kind of in the back here. And then it will be sitting something like that. We have the top as well, and I have some more foam, and I think we should just put that piece of foam in top here. But first, I think we'll connect the wires here and put the fuse on. Let's see if probably that way is better. Okay, that's very loose. So maybe we need to solder that on again like it was before. I hadn't needed to take this piece of plastic off. Okay, be back. This looks pretty cool. So the battery is mounted, and I think I just need to put on the led here and go test this out. Awesome. I hope there's enough power to see the lawnmower run, that it doesn't have to charge for 6 days or how long that will take. So I have the battery ready here to go in now. So we will be testing this in just 6 screws. And it's considerably lighter than the other 2 batteries. I don't know if that's a good thing or if it needs that weight to hold it down. And so maybe, yeah, let's see what happens. Otherwise we'll just add something with a bit of weight to it. There we are. Okay, we are ready, and Jim is filming today, so let's see what happens. Okay. See if it powers on. It does not. Back to the drawing board. Det var underligt. Okay, now it runs. I had to charge the battery. I think it was charging for about an hour, maybe an hour and a half. But Now it runs. It's gonna be very interesting to see how long. So it has been mowing the lawn for just a little bit, and well, now it got disturbed. Find the wire there. And it's gonna go and try and use the docking station and charge again. Charging. It will probably be charging for... Oh, this is not bad. 75% charge. Okay, probably the rest will take a while then. In here it's of course charging, the charger from the lawnmower, and that comes from the inverter, and that comes from the battery, and the power comes from the battery charger, which is connected to the solar panel and the windmill. So green lawn mowing. So I did a little bit of the math here. We have these batteries here. They are 12 volts and about 5.5 amp hours, and that comes to 12 times 5.5. That's 66 watt hours, and there are two of them, so that's 132 watt hours. I put in 21 cells, and they are each 14 watt hours. That comes to a total of 294 watt hours of battery capacity in the lawnmower now. So now it's charging over here. Together with that more energy in it, it's also more lightweight, and it of course it will take a lot longer to charge because the charging system is the same. Right now it's at 80%. Yeah, you can see that, 80%. Cool. So, and it has been charging for a good 10 minutes already, so probably it's gonna be slower at charging, and it's gonna be mowing the lawn a lot longer. Awesome. So now I have a lithium ion driven robot lawnmower that is driven by the sun and the windmill. So thank you very much for watching my videos. Do subscribe to my channel so that you can see me again, and have a really nice day. Bye bye.